Welcome back to Made Up of Wires. Sorry, getting set up here. Lost track of time. I don't know if you guys watch Happy Console Gamer. I've been watching Johnny Millennium for many years. Shocking number of years. But I thought this video was incredible. This weekend, he reached out to Sozu Kishiro and was able to get him, I mean, he contracted, but he was able to get him to write a theme song for the Happy Console Gamer show. And it's both very Sozu Kishiro, but also very like late 80s, early 90s anime, which fits so well with the show. So what an awesome thing. Always exciting to hear new music from him as well. And that's just incredible. I think Streets of Rage 2 was probably the first time I realized what a video game soundtrack could be. And it wasn't, I played Streets of Rage 2 before Streets of Rage 1, so Streets of Rage 2, was what hit me, and still listening to that today is an incredible soundtrack. Actually, I should take that back. Golden Axe, I remember enjoying as well. Space Harrier, though, not so much. All right. But we don't talk about music on this channel, really. Actually, we do, because I like music. We mostly talk about Decompiling, Castlevania, Symphony of the Night. I think I have most of my drama resolved with the rest of the team. So we can continue on, keep building, keep working. Some super exciting things have happened in the last week, despite my efforts to keep them from happening. So Zyynamo, who started this project, runs this website, soten.z.dev, go there to find more info, wanted to replace our make file build system for the HD and the US version of Symphony of the Night with a Ninja build system. And I've only used Ninja in passing. I've never had to maintain a project using Ninja. The only thing I know about it really is that sometimes I have to build things and they need Ninja, and I'm annoyed because I don't keep Ninja installed on my computer, and so that usually means I have to go install something. And if anything with Ninja fails, then I have to figure out how to debug it as well, which for the most part I understand how Make works. Less so Ninja. Looking at it at a superficial level, Ninja seems like a pretty straightforward re-implementation of Make and a lot of the rules, and I'm still not sure what it does internally better than Make and why it supposedly is faster. Like, there's nothing conceptually it feels like that's different. Obviously the author feels different, and others do as well. The big thing is it does seem to have a much simpler syntax. The concepts, I don't really think the concepts are terribly important. How it distinguishes how to build versus what to build. Like, Make does the same thing. I don't see the difference. Anyway, that's my own rant, whatever. So I wrote this long diatribe about how what I didn't like about the change was not that Ninja was being used to build, but that a script was being used to generate the Ninja script. And what I didn't realize was that's actually the intended way for Ninja to be used, not to use it directly, but to generate the Ninja files. And so what you end up generating is thousands and thousands of build, for lack of a better word, build script, build dependencies. And that just seems intractable to me long term. And so now we have a Python script to build build script, and that made me sad. But unfortunately for me, I'm eating my words. I can run make. Oops. Let's so running make on a built system half a second. I mean, I'm not going to complain about a half-second build. If I touch, we do this quite a bit lately. So we're going to touch Bobo 4. What would I have to do now? I'd have to extract, and then I'd have to make, and possibly something didn't get touched along the way, so I'd have to touch those files to make sure that they get rebuilt. Dependencies are modeled. Everything is fine. So we can do the same thing with the splat config. Part of this is these are modeled correctly. Could this have been done in make? Yeah, it could have been done in make, but it wasn't done in make. It was done here, and the logic to do it is procedural, and so is that going to be easier to maintain? Maybe, maybe not. I don't know. We'll see. It works though, and I can run this again. It's going to rebuild those same 37 files. That is awesome. So great job, ZINMO. Bad job, me. But what are you going to do? So we've been working on what I don't know yet is when exactly I need to clean now and when not. I'm guessing I usually won't need to clean unless there are files that get added or generated along the way. So what I wanted to do is clean up a bunch of these functions that are different for RBO5, and then we'll get parity then with RBO5 and RBO4, so Doppleganger 10 and 30. Let's look at how many are left in, I think there's 10 left. Yeah, 10. So there's 3 functions that we can quickly do. I think it's just these bottom 3. The memcard set port 1, I believe, has been done, and it's a duplicate. And so that one should be easy to do. It'll be kind of hard. It's misnamed, so it'll be a little hard to find in decomp.me, but I will find it in the dupes report. And then we could look at the other 2 as well. It should be pretty quick. It is Memorial Day in the United States, so shout out to, oh no, duplicates report is broken. Ooh, what are we gonna do? We don't have a dupes report to rely on. I might have an old one saved. I should check Discord to see if this is known. Okay, coming back to it. All right. Oh, it looks like maybe, possibly. I'm going to do this as well. Excuse me. Oh, it looks like the MIPS match stuff was merged in as well, which is awesome. So now we have some pre oh, I'm in the MIPS match branch. So I need to go back to RBO5. My RBO5 branch. Oh, I'm in the middle of a rebase, can't do that. What do I want to do? I want to I guess I could stash. No, I can't. Oh, what do I do? What do I do? I want to stash this. Can I continue without? I don't want to add this, though. I guess I can add it. What could go wrong? Sorry for this. I didn't realize that this was merged in. Ooh, missed some. What a mess. I'm just going to check out master. I'm going to abort this because basically when this change got merged in, all my commits got squashed down into one commit, and that isn't what is in this branch. So as I'm rebasing, I have to deal with all the changes between my initial commit for the PR and the last one, and that I don't want to deal with that. So I'm just going to ignore that. Check out RBO5. Let's see. Check out head or make config. Rebase this. 28. What did this say? Oh, the joys of Git. What is it upset about? Why couldn't it pick this? Oh, joy. is my branch so corrupt? Oh. Duh. Didn't I do this already? Oh, joy. Where's the end of this? All right, so this is gonna fortunately take longer than making these other changes, but it's necessary to get through to get to a clean working state again. So I'm fine doing it. And this is, I mean, this is part of software engineering. So even if you want to decompile, ultimately you have to manage software, and that is all part of the process. I've added that. So excuse me while why didn't I add this? I did. And again, this is kind of the same thing. A bunch of these were changed and so are different from the final version that was checked in was different from what was in my history. And that could be because of changes that were made in PRs. It could be other people's changes that got in between my change, and I should have added that. So we just need to resolve all these things. I'm more comfortable in this case. I know that all of this stuff has been checked in, merged into Ziano's branch, so I'm happy taking the version from Ziano's branch. And so I can kind of ignore but I can't ignore which ones I have left. And I'm guessing most of these are just going to fall away and not actually end up being any change. And so you can see some of these are, I fixed constants or immediate numbers and turned them into macros. I cleaned up a bunch of the PSP stuff. SozuD caught that during the PR. And so in master is what I want. How many left? Just one more. And as I'm adding all these, making the changes that there's no different from what is in master. No difference. So they don't show up in the diff list. All right. Hopefully this applies cleanly. Not quite. And let's see what the difference is between local branch now and master. I have DAI in here. DAI is not something that's actually going to be checked in. This was just test for. Yeah, I'll reset that for the make config changes. So now we'll make, and we have our nice Ninja build. Didn't have to clean, can rebuild, and I expect this to succeed, which is also nice. Oh, and of course it failed. That's okay. We'll see if this works. No. So we get to clean, but we don't have to extract again, which is nice. It'll do that. It'll do that for us. Oh. I need to get rid of all the DAI stuff. Okay, so we can do that. DAI is... what is DAI? Royal Chapel. So finally, we'll get to clean. This is interesting. So here's something in lib. I spent a good deal of time last week making sure segments were in alignment, and I should write some kind of visualizer for that. I think that would be kind of fun to show, given all of the shared segments we have, where they are in each file. And there's some fun diff tools that I think would be neat to use that kind of like bend around and align all of the common segments. But that is working. So let's run find again. We have 10. Oops. And 13 as expected. So let's look at this memcard set port. The reason that this matched earlier, and it might actually be interesting to run MIPS match and see if MIPS match would come up with another match for this. Yeah, I don't know. So this is taking two globals basically and storing the values of A0, which is the argument, and the value 0 at another one of these. And that is what happens in memcard set port as well, and that's why this symbol matched. This actually has nothing to do with setting the port for the memcard. It is just setting these addresses. So what this function does is really simple, and we'll be able to write this quickly. Actually, this is a fun one. We could try to write it by hand, and I think it should be relatively straightforward. We're loading this address to F4 and to F8. These are 4 bytes in size. We're storing the argument A0. It's a 32-bit value. Is it signed? Is it unsigned? We don't know. We'd have to look at the PSP version to find out. And then we return. That's it. So let's find where that is. We're going to grep for mem card. Let's see. Set port. And yeah. Recursive. Just read my mind commands. It's in Doppleganger. And we don't know yet where or what this is for. So I'm going to leave it called memcard set port, but we might know what this is called later. The other thing I want to look at, drat, I didn't keep that file open. Is V0 getting set? It's not, so we're not returning anything. So we do have a void function. So that's going to be mem. Oop. I'm not showing any of this. Let me move this to a new tab. Was it here? All right, so this is what I was saying. We have one global 32-bit addresses need to be loaded in 2 instructions. We're taking that address. This could be a pointer. I think it's just an address. But we're storing the value of A0. We'll see in a second if that's the case. And then the second one, we're storing just the value in register 0, which is always 0, and then returning. Almost universally, return is always a JR. So jump return to the return address register, and followed by a no-op. I mentioned before, the branch delay slot, every branch or jump instruction will execute the instruction immediately after it. The PSP is slightly different. There are conditional branch instructions, which will only conditionally execute based on another argument. Those are weird. So let's grab these. We don't know much about them, but we can find out what those addresses are. I'm going to paste these here so that I have them as references. Right now I'm going to say that they're signed 32s. We don't know where they are yet, so they're going to be extern. So we're going to have one here, and then the other one is 4 bytes later. We're going to take a Sign32 arg. We'll call it arg0. Arg0 is going to be assigned to this value, or this global, and then into the one right next to it, which is 8. We're going to set 0, and then that's it. And is this going to work? Maybe. If these are pointers, it's not going to work. But if they're just global references, it is. And we'll find out in a second. And that worked. So that's it. So sometimes you don't need decomp.me. You can just do these on your own if you recognize what's happening. I think it might be good to look for these addresses and see if we can tell where they are. These might not be signed 32s. They might be something else. I think this function is probably going to be used in one of these 2 functions down here, which I believe these are all the unique ones for Doppleganger. And let's find out. 290 is, I guess, the only other one that's in Doppleganger. All right, so let's look at that and see if that is one of the other ones. It is, and I want to see if memcard set port is used in any of those. Non-matching's Doppleganger. Recursively. Yeah, it is. So it's used in 290 as well as 1DC8. And 1DC8 is a larger function. I believe this is a function that exists in Doppelganger 10 as well, but we'll have to see. All right, so I did find out that the dupes report is it is indeed failing. That's a known failure. All right, so let's look at, I think D90 is probably the next one to look at. It should be relatively small. What is curious, without the, let's see if I have a dupes report. It's not going to be recent. Well, it does have some things in it, though. Let's look at this 2D90. It's not in there. Let's look at this DC8. It also isn't in there. So these are unique, completely unique to Doppelganger 40. So a relatively small stack, 32 bytes. And just some assignments, it looks like. So hopefully this one goes quick. We will go to decomp.me for this. Anything over a dozen or so lines, I would always go to decomp.me. And decomp.me uses M2C to do a initial decompilation, as well as having the nice diff between the two. So we have a bunch of things that we don't know yet. Entity Doppelganger 40 is actually in that Doppelganger file. This is a void. Not sure why. This is a void, and I made it sign 32, but we don't know that for sure yet. So that's an assumption that we're gonna have to go with. Several of these other ones, if the return value isn't being used, come on. Then it doesn't matter. And most of the time, at least on the PlayStation, these are unnecessary anyway. This one possibly, this 4954 function, we may want to get the arguments for that just in case that there's something other than 32-bit. Let's look that up quickly and see if we have. Okay. Oops, I got rid of the wrong one. These others I'm just going to delete. And we'll use the default values there. So we have all of these. I'm going to throw them into the context. We're on the M2C again. And now it will have additional types that it can infer other things from. And that, for example, took care of our unknown variable in there, which just makes things a little easier. Our arg here, most likely, and we could check this too, most likely this is going to be an entity pointer. But let's check. We'll see. Let's look at boss RBO5 data. And this is near the beginning. I'm guessing these are other entity update functions. If that is the case, then the arg is indeed entity. Yes. So this is an entity update function, and so we'll give it the entity update signature, which will also allow M2C to know more about this entity self. And we'll get this to decompile again. And then we can get rid of these, and it should be compiling. 85%, not too bad. So the middle column is what we want our match to match. Out here is what we are currently generating with our C code, and of course here is the C code. So there's a couple things to fix. Doppleganger, this symbol is a placeholder because we can map symbol names to specific addresses, but we can't map field access into a struct. But we can replace that. Sometimes that will generate the right code or the code that you're expecting. Sometimes it doesn't. And then the last one is this entity that's kind of hanging out in the middle. This is in the entity table, but it probably is not at an index that we necessarily know about. So it's a well-known index, but not necessarily one that we know. So we need to figure that out. And let me see if I have my calculator. I usually don't put this on screen because it goes pretty quick, but I will. Oh, where'd I go? I'm a calculator now. Maybe this is better. This is a stream improvement. So, oops, wrong. I can't get the D in there. Actually, the underscore is what's causing the problems. So I'm going to take this offset, or the address that is assigned to this variable. This is something that SPIM creates automatically when there's no other symbol. It bases it off of where it's going to exist in RAM when it loads. The compiler comes up with that address, but then SPIM turns it into a variable with the name of the address. I'm going to subtract the start of the G entities table. I was just thinking about this phrase the other day. G entities is a table of entities where each an array. We call it arrays mostly now. We don't use the word table, but it is often called a table. Each index in that table is one of the 128 entities that can be allocated at any time. 128 or 256? One of the two. 256 maybe. So I'm going to take that symbol address and subtract it. The phrase that I was thinking of is the value of the label, G entities being the label, is the address of the table. And we come away with 31FO. That's how many bytes into this table we are. We need to divide by the size of the entities in that table, which is BC. So that gives us offset 68. looks like 44, base 16. So 68. So this is the same as saying G entities. We could say 44 here. We could say 60. I'm going to say 68. I prefer decimal when possible. And programming requires you to spell things correctly. This gets us a little further away. Some of that is because of symbols. Symbols are not correct anymore. This is actually not recognizing this as a real address. The way that addresses get loaded is really bizarre. I don't necessarily understand how GCC configures or creates this. And I've been meaning to look at Rabbitizer. Rabbitizer will kind of track registers for you and allow you to come up with these symbols or the offsets. I will have to look at that though later. I'm not showing you any of this, but there it is. Oh, and I'm done with the calculator, so I can get rid of that too. Boom. There I am. All right. We haven't looked at any of the code yet to see what any of it's doing. That's okay. I think that's what we'll get to soon. We have a couple globals. These are actually part of the entities table as well. And so we'll have to figure out what those are. These are addresses that I don't have mapped to anything. So we're going to have to go back and map them manually. So we're going to do the same thing. We're going to take that offset, subtract the start of G entities. We're going to divide by BC. So this is something that is at entity 64. Entity 64 is Doppleganger. And we know what specifically that address is. It's at entity 64. So what we need to do is go back and take that original value again, which is this one. Subtract the address of entity 64, which gives us 3C. Now we're going to take that offset, look at the entity structure, and see what value is at offset 3C, hitbox state. So everything that is using this 314 is actually doppelganger.hitbox state. And likewise, everything that's using the one right after it, the 316 variable, that's going to be hit points. So this is something about hitting, like when Doppelganger gets hit. And we can get rid of these, and that should help a little bit. My guess is that some of these other ones fall in GDOP, and that's going to be painful, but we'll get through it. So let's look at that. GDOP is a player state that's custom to Doppelganger. So we call this structure player state because it had only been used for the player character, Richter or Alucard, up until the point where we're dealing with Doppelganger. Doppelganger does a lot of things the same way that the player does. And so there is another player state specifically for Doppelganger. And so we need to figure out if anything is within the bounds of that struct. So what I like to do is take that address, throw it up here. These other things are all starting at what looks to be in that address range. Am I still a calculator? I am. So a player state is 3DO in size. So this is the end of the player state. So any of the fields that come after this 3FFO address, but before this 343CO address. Those are going to be in that GDOP. So all of these are. So these look like globals, and they are global, but they're part of the GDOP struct. So we have to work out each of these. This sucks in a lot of ways because there was only one player state. We don't have relative offsets. We just have addresses for the Alucard version or the Richter version. And so I have to figure out each of these uniquely each time. And that's done by making myself a calculator again. And finding the offset. So in this case, it's 3CO. And then I'm going to have to find the equivalent in the player state struct. And this is tedious. And the reason I haven't done better, the reason I haven't gotten good, is because I feel like this is almost over. There's only a few functions left. And I am lazy. I'm so lazy I could have seen that these were all 2 bytes off from each other. And just done the math in my head. These are actually much better than I expected, because they all are towards the end. So we have 16 bytes from the end of that structure, and then everything else is 2 bytes before it. So this should be pretty straightforward to solve. So we're going to look for a player state. Find 16 bytes. So that's going to be 8 16 bits or something else. I don't know. So 2, 4, 6, 8, 12, 16. Yeah. We're starting. Yes. So this is unknown 70 is the last one. And we're going from unknown 6A to unknown 70. Oops. Too many copies. So we're going to look for that, and we're going to replace it with GDOP unknown 6A. This becomes C. This becomes C. Do it again. This becomes E. This becomes E. Do it again. And then the last one is 70. Oops. AE becomes B0. And we do it one more time. Then we can get rid of all these. And we're left with one global. Let's see if we have this global used anywhere else yet. Close all these. This is specific to Doppleganger. So we're just going to, or specifically Doppleganger 40. So we're just going to look at things in the RBO5 directory. Nothing is using that. Let's look at ASM US. ASM being assembly US. Boss RBO5. And see where else this is used. It's only used in this function, so all we know is that it's a the size is word. M2C marked it as an unsigned though. So either M2C is wrong or M2C is wrong. It's actually an E in it. All right, so that's the correct symbol. It's basically an initialization structure for another entity. And that's it. So there's a couple things here that may be relevant. We should probably look at as well, just for general cleanup. We have a bunch of fields that are like various stages of hit points and hitbox state. If those are used consistently, it's possible. it looks like basically these are flip-flops, not the right word. Like shift registers, I think, is the right concept, where we're going to set all these things to the right thing, shift one over, update the last one, and that way we can kind of maintain like what was the previous state and what is the current state, so that functions that get called later can figure out if something has changed. But we haven't actually really done anything except mapping variables. I'm going to save that, and let's start figuring out what is going on. Var S0 is going to be an I type variable. It looks like we're going to say for I equals 68, while I is less than x90, which is too big of a number for me to figure out. 144. We're going to, I think, just destroy the entity at I, and this var S1 is going to go away. Var S0 no longer exists, and that helped quite a bit. GCC will often do that in its optimizer. It'll see that we're indexing through G entities. To compute that address, it's going to have to take this base address and then add, multiply I by the size of the entity in that array, which is BC, and then add that all together. And so that's at least two operations. What it could do instead is hoist this out. It knows that the first entry is going to be offset 68. So grab that address, and then at the end of each loop, just increment that address by one entry, or BC in size. And then it only has to do one operation. So the optimizer came through and tried to figure out how to do that. And that's what it did. This condition, whenever we see this also is a GCC optimization for reasons I don't necessarily understand. Instead of a greater or equals, almost universally these are less than, and then we need to change the condition. And those ended up being backwards. Not sure why. Also, this may not be a separate variable. This may just be setting. Now this makes sense. There we go. And so I think we got rid of var v0 in that. Now we're getting pretty close. We're at 94%. This is going to be the same thing. Memcard set port, as we talked about before, is not the right value. We're not setting a variable either. We're going to be calling it up here if player x high is greater than or equal to 81. Actually, we'll do this. We'll flip that around, do the opposite. And this looks like it's setting some kind of flags for this outer variable. And this ends up generating the same code, no difference. But we can get rid of this as well. And we don't have a var s1 variable either. So we're not done yet, though. There's something rotten. These are all getting assigned in order, which is probably fine. Okay, so we just have some register issues. Let's look here. So we're using register S1 instead of S0. On the PlayStation version using GCC, that's not super obvious why something like that might be happening. Here it is, 22. This should be less than 80. But that does not help. Let's put these back to the order they were. That gives us the wrong... All right, greater than 80, that looks fine. This one is... All right, so all those are correct. Really, we just have this one register. So this could be... let's try this. So I'm going to add a entity pointer. The entity pointer is going to take a reference to G entities at 68. I is going to go from 0 to 76. And entities plus plus? No, entities. Yeah, that should be fine. Entity. That's worse. So let's pass entity there. We'll do this same thing, 68 to 144. But then we will increment the entity here. And that's it. Our entity size is wrong. It's off by 4 bytes. Let's figure out why. Why would our entity size be off by 4 bytes? Oh, there must be an extension that's off by 4 bytes. So this C0 is wrong, but everything else is fine. So I think this will work the way it is, and it's a reasonable implementation. I'm no concerns. So we'll take that over to GDOP. We're looking for the 2D90 function. We're going to replace our include ASM with that function from decomp.me. And it worked. So another one in the can. What time is it? I got time for one more, I think. So these continue to show up in the dupes report, or not the dupes report, my find, because the assembly files don't get deleted when I'm finished updating them. Let's look at this one. This may or may not be a little trickier to get done in a handful of minutes, but maybe. I'm going to do a couple things. I am going to create a new scratch here. We'll use PlayStation. I want to check to see if anybody has started this, including myself. Somebody did start it. But so there's gonna be a couple things likely. How long ago? 2 months ago? They're not gonna necessarily have all of the symbols and stuff that we had, because a lot has changed in the last 2 months. So I could fork this and work from this version, but I know that there are other symbols that have changed, so I'm not going to use that one. So I'm going to use a fresh one. The other thing I want to do is look at the dupes report. Oh, what was it called? Duplicates. I need to rewrite the duplicates generation logic so that it doesn't completely demolish an environment. It's not in the dupes report. Okay, so we don't know yet what this does. So I think we have enough information, though, to keep going. Actually, we could get one more piece of information that might be valuable. We'll see. Let's look at where this is used and what it might be used for. We'll look at RBO5, ASMUS, boss, RBO5, look there as well. This does look like it likely is an entity update function, because nothing calls it. And it's just in this list. And there it is. So yes, this is an entity update function, which means we have the signature, which means we can start off with a context that has the right signature and argument name. That'll give us something a little nicer to start with. We have two functions which we can provide signatures for. Player collision with. We don't need the extern label. Functions are always extern. And then this other one, it does look like that is specific to RBO5. Oh, and that is a nice type to know. All right, so we have those two types. We'll throw those into the context. Run M2C again with the decompile tool and get a new starting point. And so now we only have one unknown variable in global, and nothing, no unknowns scoped to the function. Locals. Okay, so what do we know? It looks like an unsigned 16 array. I'm going to grab that variable name. I'm going to grep for that unknown variable name both in the existing sources as well as the stuff that has not been decompiled yet. It's only used here. We can look at data. Let's see where this is. And this looks like bytes. So we have pairs of bytes. The reason it's being cast as an unsigned 16 because that's what facing left is. So I think this is just pairs of bytes which are being treated as booleans. A boolean in C, the bool type is the size of an int, so we can't rely on that. This is 1, 2, 3, 4, 5, 6, 7, 8 in size. May or may not help. And so something like this line down here works because the value of the label is the address of the table. An array variable's value is both the start of the array and can be indexed, but it's also a pointer to the array. It can be used either way, or thought of either way, that it's the same concept. So I'm going to start cleaning this up. We don't need a separate variable for the step, especially when it's only being used like that. As I clean those up, we should get closer. We may get further away for a time, but hopefully we come back and are able to deal with that. We'll check those out later. Anim set. This is, I need to take the 2's complement of that. We've seen a couple issues there as well. So that's going to be the same as 15. So we do this, we say it's an overlay anim set, and it's going to be 15. Sometimes this works the way it's expected, and sometimes it needs to be cast. In this case, it does not need to be cast. This becomes array access. We have a couple go-tos. We could resolve those. That's nice to resolve. So in this case, we're just setting the step here. It's setting the step to 4 and then returning. Otherwise, it's doing something else. The default falling inside of here and returning, that's what would happen if default was outside as well. So we can just get rid of that. So block 44, this could be a break as well. And so I'm gonna try to write it as a break. I think it's only ever used in this one other place, but we'll find out. These always seem like superfluous optimization. However, when you're writing a optimizer, you don't always know what is going. I mean, it probably saves a little bit of time, and so you can justify that savings, even though we would never write code like this. So now everywhere there was that go-to, we're always going to have this pattern where var v0 gets set and then step gets set, and we can get rid of all the var v0s. And most of the time we can probably get rid of the break as well. Because these get optimized to the same thing, it usually doesn't make that much of a difference in terms of how close this code is. This one did. All right, is that all the go-tos? No, we have one more. Lock. Where is that block? Where are you, block 42? Oh. Where is block 42? I got rid of it. I meant to get rid of block 43. So block 42 and block 43 look like they're the same thing. I like to do these by hand anyway. Some care needs to be taken to make sure that when this happens, that it's always going to fall out, because that's what block 42 did. It incremented the step and then it returns from the function. So everything that calls it also needs to return. But that looks right. We're up to 94%. And so I think that gets rid of all the block 42s. An easy one is GAPI. Again, these are symbols that we've mapped because we know where they are in memory, but we can't write the symbol as if it's a struct access, even though we know that it is, and so all those need to be fixed. A lot of times this means instead of using the JAL instruction, and I got this one wrong. This is amset OVL. Instead of using the JAL instruction, we're going to use the JR instruction, which is jump register. All right, what should we do next? I'm going to go through just quickly and see what common idioms do we see. So there's things like this, setting a variable and then setting the position. That usually doesn't happen. Usually the position is set right in line and just on both sides of that branch. And this is actually incrementing or decrementing that position. This is pretty common. And different games are going to do things differently. But this is how this game works. Facing left is almost universally checked as a Boolean. Here we're looking at position Y versus the tile map scroll position, checking that against hex 39, which is 63. Hey, Dig Down Deep. Oh, I'm calculator face today. No, I had it up earlier and forgot to take it down. Thank you again for helping with my poor screen management. I can't see me in my current window setup. I can see the window that I'm showing you, though. So this is kind of an interesting one for allocate entity. Temp fee 0, I'm going to rename as, just make sure that I don't have it, I'm going to rename that as entity. So we want to create a new entity. Probably slightly more than that, but I do appreciate it. Get back to this alloc entity. So we're creating a new entity. We choose an entity that's in the entity table that is currently not being used, and I think that's things with entity ID 0, if I remember correctly. So the memory's already allocated for them. We can just stick whatever we want in those structs as long as entity A0. I think allocate entity also clears out a bunch of stuff as well and makes sure it's uninitialized. So what we want here is a reference specifically to this index. And then now I'm going to put the calculator back. What is this index 20 further along? And because I'm thinking about it, I'll get rid of that. So this will go to 192. That was hex. And we won't be able to check those values in decomp.me, but hopefully that works out. There's a bunch of things with velocity that we should probably change. Self, let's look at the entity structure. There must be a tile map pointer as the first. No. How does this work? Oh, was I? No, I don't think I was wrong. We're passing self as a tile map. That doesn't make sense. So I must be wrong about this 5004 function. Which sucks because this is used elsewhere. Or this is a bug. Could be a bug. I'm gonna go with bug. So we're casting an entity as a tile map, and we can look at the PSP and see if this worked. MetroWorks may complain about this when GCC does not. I am going to clean up a few things though before getting back to that. Temp A0, that's GCC optimizes how we'd see in GCC in. I'm fairly certain that these are going to be their own unique thing and not be a separate variable. I could be wrong, but I'm going to go with that. Get my parentheses back. Here's another case. Self being passed as a tile map. That's weird. Oh, looks like I might be wrong about that. There was a variable there. Okay. We'll call temp A0 scroll Y. And we'll use scroll Y down here as well. And use it here as well. Oh, I screwed that up again. It's the casting that I screwed up. Okay, so the variable's not necessary, it's the casts. All right, well. That happens sometimes. This is the same pattern that was down below. So we're kind of stuck in this 92% range, going back and forth between that. There's casting that may be necessary down here that I was missing. I don't remember what those casts look like. I'll have to go back up and look. A little bizarre, but like not the craziest. U16, S16. There's this 3F. Is that... Did I screw that up? Likely. Yes, I did screw that up. So 3.9 is going to be... $57? $132. Mask is wrong. No. What's wrong with that mask? What an odd mask. So the reason that, and this is such an odd thing for GCC to do. So it sees that temp S2 was multiplied by 2. So therefore, it's never going to have the bottom bit set, because multiples of 2 would never have the bottom bit set, because that immediately makes it odd. So it only masks everything but the lowest bit. What a bizarre thing. So let's try this. What if we change this to a shift? Is it still that smart? It is. Oh, gross. That's gross. So I think what's happening, let's try this instead. Our 5004 function, maybe it takes a sine 16. That's implicit. So let's go back to that, 132. I think that... Okay, let's try unsigned 16. I can never remember which one gives you the mask and which one doesn't. It still gives the wrong mask. What about an unsigned 32? And then will I... Somehow we need to launder this variable to convince GCC that this is it may or may not have that bottom bit set. I'm going to do the shift because that's how it looks in 5004. Temp S2, the plain one is going to become params. Let's do this. No. No, let's not do that. Okay, so something's up with that. I don't know how to deal with that at the moment. I think I'm going to go grab, there's a few things to clean up here still. Pretty minor, but I think I'm going to go grab the PSP version. Let's see if there's returns anywhere. I got all those. Let's see if there's plus equals ones anywhere. I got all those. And let's find something unique. The B is pretty unique. Not a common number. 11. And we got it. We're using it a couple different times. So I'm going to look for that. Bummer day. I don't have... this extracted anymore. So we're going to use the brand new... No, not brand new. But recently improved make config with enhanced symbol matching finding matches across overlays. That's the MIPS match stuff that I've been working with before. Before, we had no symbols for PSP functions. Not quite. We had very few symbols for PSP function or for PSP overlays. And now, if we look at the symbols table, actually should probably work with the Splat team on this. Look at all the beautiful symbols, all coming from Match. So each of them has a comment, tells you where they came from. Lots of nice things. We can have nice things. So we're looking... oh, but I didn't want BO4. I wanted RBO5. Much faster than Dupes. Dupes still runs on the PlayStation version. Just not on the PSP version. It never ran on the PSP version. We should get Dupes working on PSP because people are working on that more. So we want to look for, I think, yeah, hex B. In non-matchings. But not for US. For PSP. And that's going to be RBO5 PSP. We want things that end with XB, so we can add a $sign to our search. And I think I can just put that there without escaping it. Yeah, I can. How many times? I don't know. Let's come up with another unique value. The sound effect ID is good. We have 655. That's it. What if we started with 655? Would we have gotten the right thing the first time? Should I always look for... Yeah, we would have. I should always look for sound effect IDs first. They're pretty unique if you get them. I'm going to copy that. Roger that. And we'll go over to the PSP. Make a scratch for that. Scratch that. That could be some kind of radio operator. Ooh. So we're missing a jump table for reasons I don't know. We don't need it because we're not using that code anyway. We're just using this to help match. It's kind of a bummer I didn't choose the right preset. We won't get... Oh, bummer. We won't get an M2C version, but that's okay. So here's a few things that we're going to find, possibly. Is the ordering here what we expect? It looks like not. Are we loading this multiple times? Maybe. SLLV, that's an instruction that I've not seen. SLLV. If I can find that. So I do see documentation on Stack Overflow about SLLV, which maybe just requires that the shift amount be in a register. Yeah. So we have a register. Load me. We're gonna say shift equals 1, and then we're gonna shift. But why? Why? Let's use shift down here as well. Not quite right. We didn't look up these variables to see what they may or may not be in reality. Boy. So this is a little odd. Really bummed that we didn't get M2C, but that's the way it goes sometimes. I'm going to clean up these variables up top. I think we got rid of most of those along the way. Happy Memorial Day, everybody. I should have a... Why didn't I put a big waving flag behind me? Everybody knows America's the best, right? The best. What's kind of funny is in the 80s and 90s, I think being of the generation that I am, which is Gen X, the best generation, I was totally apathetic about Muruka. and really didn't care about it at all. And now as an adult, I don't care as much as maybe super patriotic people, but I am not sure where the current. I didn't ever have the disdain that I think a lot of the whippersnappers have. Don't really understand it. Ultimately, it's the country. This is where I was born. This is where I'll die, probably. Oh, is this why? So we had the shift in the variable here. I'm going to try taking this back over. We have shift in a variable, and we're shifting it down here. It's possible that this variable is used elsewhere. Probably should do a better job at tracking it. But because it's in a variable, which gives us the SLLV instruction, possible that GCC. No, don't. It's possible that GCC won't do that mask optimization. Let's see. Worse. And it still does the mask optimization. I'm going to keep this one high until we get this one higher. I don't understand the ordering here. Yeah, it's only going to make the ordering worse. No idea. All right, let's keep moving down and see where I screwed up on other things. So we're computing facing left. Temp S1. It looks like we're doing this load. So something from the stack pointer. Oh. Oh. Well, my first thought was maybe this whole business is getting moved somewhere, but no. Okay, so setting priority is happening much later. Maybe not much later. It's happening later. Okay, that fixed it. It was just the priority being in the wrong order. There's a mask that's not happening. The mask is happening first. Okay, same thing here. It's like every time we use this, it's getting masked. Annoying. Hmm. So something more is happening here that I am missing. Oh, these are maybe opposite. Yeah. Weird. Uh, 54. So here there's a bunch of sign extensions that shouldn't be happening. It looks like scroll Y maybe is getting pulled out into a variable. Oh, this is also where I took out a bunch of the casts. Okay, that brings some of them back. Let's make this an unsigned 16. Let's make this a signed 16. Not quite. So there's some pattern there that needs to be resolved. I may do this, may switch this to a less than, and we could break here and short circuit this. And it doesn't seem to affect that either way. Oh, there we go. Still missing a sign extension. Yeah, we'll have to figure out what that is. This is 128, right? Hey, Joe Rawlings. Good to have you back. It can. I had some free time this afternoon, so I thought I would do a little bit of work today. But my time is actually done, so I can't keep going. So we're 78-ish% on the PSP. Going back to the PlayStation, that's actually much better. Oh, I know. I was just mentioning how I need my American flag waving behind me. But not today. So that's all I'm going to do for now. I'll keep working on this tomorrow, and hopefully we'll get these done. We have a few more of the unique Doppleganger 40 functions left. You can go to soten.z.dev. I do want to point out how, like, this is the most computer sciencey thing that I've done in a while. So with the new overlay generation stuff, we are using Rabincarp rolling hashes to match identical functions between overlays. We can find segments. Let's look at that too. That could be cool. Yeah, we find all the segment offsets. What's missing, and the reason that these are commented out instead of just getting generated for you, all of these correspond to a C file. And that C file ultimately is going to have RO data that's associated with it as well. And we need to break up all that RO data. And unfortunately, that's not a problem that Rabincarp can solve. But pretty cool stuff. Pretty cool. Go to soten.z.dev. See more. We've been working on Doppleganger 40, getting to the end. BO4, RBO5. 95% of the way through all the functions there. And we should be equivalent after tomorrow on RBO5 as well, and just have the matches, save one, between the two. So that's Z.dev. Join us on Discord. And track what's changed here back on GitHub. Adios. Good to see you, Joe. Good to see you dig down deep always.